was the number the user was trying to guess? That's a variable. And what's the name of our variable? It's secret number. So after it runs this line, it will generate a number between 1 and 99 and put it in a variable called secret number. Fantastic. Then it says something to the user. It says, I'm thinking of a number between 1 and 99. It doesn't tell the user that it's actually thinking about the number 92. Then in this next line, well, we've seen this a whole bunch. It asks the user, could you enter a guess, takes the response that the user gets, turns it into a number, and stores it in a variable called guess. So at this point, we have two variables, one's secret number and one's guess. So let's say the user just guessed a 50. 50 goes into this variable. Great. Now we enter a loop. Why is there a loop? Because we're going to be asking the user many times, what is your next guess? We don't want to say like, oh, the user's going to ask 100 questions. The user could answer 1,000 questions before they get the right answer. We want a loop. We don't know at the time of programming how many times we want to repeat. So we don't want a for loop. We want a while loop. We don't know how many times the user is going to have to guess a number before they get the correct answer. Enter the while loop. When do we want to stop this while loop? This while loop stops when the guess is the same as the secret number. In other words, we're going to continue with the while loop while the guess is different from the secret number. So as long as the user hasn't ended up with the secret number as their guess, we're going to keep repeating. So at this moment, is guess the same as secret number? No, guess is different. Guess is not equal to secret number. This evaluates to true. It passes, we enter the while loop. Then we hit a if statement. Is the guess less than secret number? Is 50 less than 92? When it sees guess, it knows guess is a variable. Let's look at its value. That's 50. When the Python program sees secret number, it thinks secret number is a variable. Its value is 92. This whole statement then evaluates to, is 50 less than 92? Yeah, 50 is less than 92. So it prints, your guess is too low. Doesn't do the else statement because the if statement just passed. So it goes to the next line. We just told the user, hey, you guessed 50? 50 is too low. Then we need the user to give us a new guess. So the last thing in this while loop is, let's get a new guess from the user. So let's say the user now says 95. So the user just guessed 95, and at this point, we loop. So just like in Carol, we at this point jump up to the top of the while loop, and we're going to ask, is guess different than secret number? So we go back to the top of the while loop, and we say, is guess different than secret number? Yeah, guess is different than secret number. The current guess is 95, current secret number is 92. 95 is different than 92, so this evaluates to true. Those things are different. Then, is guess less than secret number? No, it's not. So we're going to execute the else and it says print your guess is too high. So at this point, the user just guessed 95, we told them it's too high, and then we print an empty line. Then, now that we've told the user, hey, your first guess of 50 was too low, your second guess of 95 was too high, we get a third guess from the user. Let's say the user now writes in 92. Hey, lucky user, you guessed correctly. At this point in the program, it now goes back to the while loop. And before it repeats the while loop, it asks, is guess different than secret number? But this time the answer set is false. Guess is not different than secret number. In fact, they're the same. 92 not equal to 92, that's false. So the while loop now has a condition which is false. As soon as the while loop has a condition that's false, it stops running and it says, good job, you won the game. Your secret number was 2. So let's go play it, and then we're going to talk about how someone could have programmed that game. So here's guess my number. Here's the code I just showed you in the slides, and we can run it. It says, okay, I'm thinking of number between 1 and 99. It's like, I know it is, it's 92. No, it's not 92 this time. This time it's chosen a different random number. Every time this program runs, you get a different number between 1 and 99. That's the secret one. So let's try 50, too low. Okay, 75, too low. 88, too high. Okay, it's between 75 and 88. Maybe it's 80, maybe it's 85. 85 is too high. 82, too low. 83, hey, it was 83. Congrats, the number was 83. So here's this program. Makes a secret number, tells them a little intro, gets a first guess, and then repeatedly checks if the guess was too high or too low, and then gets a new guess. Eventually, when the guess is the same as the secret number, you're done with the while loop, and you get to say congrats, the number was, in this case, 80. So at this point, I've showed you a program that's fully formed. What I haven't told you is how a programmer might have gotten from empty code to a solution like that. Let's go behind the scenes and think about how someone could have arrived at that cool piece of Python code. When someone's writing guess my number, I imagine these 3 lines are a nice place to start. This first line generates the random number that the user will try to guess. The second line just prints a little intro, and the last line prints the message at the end where you actually reveal what the secret number was. This part's pretty straightforward. Then the programmer imagines they're going to have a variable called secret number, and inside that secret number will be whatever number was randomly generated between 1 and 99. Now, I imagine if a programmer was solving this problem, the next thing they'd think to themselves is, I gotta repeatedly ask the user for guesses and tell them if the guess is too high or too low. I want to repeat. I don't know how many times I want to repeat. I want a while loop. So imagine this is how a programmer solves the program. In that while loop, what do I want to repeat? I want to repeat getting a new guess, and then I want to repeat telling the user if it's too high or too low. I haven't figured out what condition I want for the while loop. I just know I want it to repeat a bunch of times at the moment. So, getting a new guess. We've seen that a whole bunch. That's just asking the user for a whole number. Let's ask the user, give them the prompt to enter a guess, take their response, turn it into type integer, and store that in the variable. And at this point, we might feel ready to write the condition for the while loop. We have a secret number, we have a guess, and don't we just want to keep going while the secret number is not the same as guess? This is a really reasonable approach. A lot of students, if we gave them this challenge, would get to this point, and they would write this exact code, and they would run it, and there would be a bug. Alarm bells would start to go off and it would crash, and the program would say, I ran this program and I got to the while loop and it says guess, and I've never heard of guess. Well, there's a problem here. The program's right. Guess isn't defined until this line of the program. So when your program runs one line at a time, it gets to this part and it says, I haven't seen a variable called guess be defined yet. And in fact, we kind of have ourselves a fence post bug. You know, we want to get a certain number of guesses, and one fewer time we want to report higher or low. So it's like we have fence posts which are getting guesses and panels which are reporting higher or low. And we want to repeat this loop 1/2 time more in terms of getting a guess. We've seen this in Carol a whole bunch. It's like when you wanted to make a row of beepers and you had to place one more beeper either at the beginning or the end. So in this case, you can solve that loop and a half for that fence post bug by getting one more guess at the beginning of the program. So here I'm going to rearrange this. So the programmer's like, oh, I had a little mistake. I hadn't defined guess before the while loop. Why don't I rearrange my program like this? Let's first get a guess, and then let's repeatedly report high or low, and then get a new guess. And this way, we'll end up with one more guess the number of times we report high or low. The fence post bug. Oh, our program is feeling fantastic because that was a pretty hard intellectual challenge to solve. Then it's time to write reporting high or low, and they could write something like this if statement. This if statement checks is the current guess less than secret number. If so, print this, otherwise print too high. And at this point, they are done. So that's the behind the scenes journey of how you go from no code to this really awesome guess my number game. Join us in the next video, and in the next video, it will be your turn to try and solve a problem. Okay, in that last video, I showed you a cool game called Guess My Number. In this video, it's our turn to program together and try and solve a problem. The problem for us to try and solve as a team is Sentinel Loop. And the way it works is you ask the user for numbers. The user is going to keep entering numbers until they enter a special number, which is -1. When they enter -1, the program's over, and I want to output the sum of all the numbers they entered, not including that -1. So if the user enters 10, then 20, then 30, and then -1 saying they're done, then we're going to report 60, which is 10 plus 20 plus 30. So this is something for us to do together. Your task is to write this loop, this Sentinel loop, and you might not know this, but every single lecture comes with a lesson where you can go program. I would recommend that you go to Ed right now, and if you go over to the Lessons tab, if you click on Lessons, you'll see Lecture Steps Control Flow, and here you'll find Sentinel Loops. I recommend you pause the video right now and you give this a shot. Can you write this program? And then come back and we can do it together. Okay, I assume you just paused it and then welcome back. Let's try and program this together. Sentinel Loop. So here's the program, and it's got some sort of blank code, the sort of stuff you look at in your assignments. It's intimidating. It has to be filled in. It's got this path for main. Well, let's do this step by step. The first step is, can we just repeatedly ask the user for a number? We don't need to print the total. Let's just repeatedly ask the user for a number. If we want to repeat, we want a loop. And this time we want a while loop, because at the time of programming, we don't know how many numbers the user is going to enter. So a while loop needs a condition. I don't know what the condition is yet, so I'm just going to put it true, which means just keep looping. And every time in the loop, I'm going to get a number from the user. So let's ask the user for a number. And let's say, user, type a number. Now, as we know well by this point, if you ask the user for a number, Python still will give it to us text. And so you have to say Python, put that through the integer function, which gives it back to us as a number. Fantastic. We have a program, and it repeatedly asks the user for numbers. 10, 20, 30, -1. Hey, you're supposed to have stopped. This program never stops. It will always ask the user for another number. So, as a next milestone, can we get this loop to stop? Can we get it to stop when you enter a -1? Well, there are a few ways of doing this, but using what we know so far, we'd have to solve this problem by changing the condition. And it seems like the condition for continuing to repeat is that the user's number is not -1. You could write -1, or even better, we could use this constant. So as long as the user's number is not -1, keep going. Fantastic. This seems really good. Run the program, and it crashes. This is going to happen to all of us. This is a very common crash. Whenever you see a crash like this, it tells you what line it crashed on. It crashed on line 9. And then it tells you why it crashed. It says local variable num reference before assignment. That might sound complicated, but Python's telling you exactly what went wrong. It says, I tried to access a variable called num, but at the point of this program, no one's created a variable called num. You know, Python starts the main, and it gets here, and it's like, what's this num that you referred to? Like, oh yeah, I never created a variable called num. So, if you think about it, maybe we want to create a variable called num, and we want to do it outside the loop. So, let's create a variable called num, get a number from the user, and then let's keep repeating while that number is not the sentinel. So we can try this again. Okay, we got 10, we got 20, we got 30, now we put -1, and it stops. Program exited with code 0 means that the program exited without any errors. That's great. It almost did the problem. The only thing left to do is to print the total equal. So we want hot. Okay, hopefully you paused and gave yourself some time to think about this problem. How would you print out the first 100 even numbers? Okay, so it's a Friday. I want to leave by each time. So 100 and then just print I and just see what it does. Try that at home. It's so useful. Using the index in an iterator is such a core concept and something you'll become really good at. Since you guys are here, I thought I'd show you a little bit of an advanced version. Here's another way of printing out the first three even numbers. Instead of doing for I in range 3, there are other versions of range, and you can go check them out. One version of range is, instead of putting one number, if you give 3 numbers to range, it interprets the first number as the start value, the second number as stop. Good morning, everybody. Welcome back to another great day of Code in Place. We have a fantastic lecture for you, as always. And today marks the beginning of your third week of class. This week, we're going to learn a whole bunch of great new topics. You'll go to your third section. And on Friday, you can submit your sandcastles for assignment too. And if you have time, definitely try out some of those optional challenges. They are fantastic. Okay. So today we're going to be learning about functions. Fantastic idea. Before we jump into that, as always, though, let's do a little bit of review, because we talked about some incredibly important concepts last week.
One of those important concepts was we introduced you to this variable type called a Boolean. Boolean's like the most simple variable type. It can only take on two possible values, true or false. And here's two examples of Boolean. The first one creates a Boolean called Carol is awesome, sets its value to true. The other one called myBool, and also sets its value to true. But the way it sets its value to true is it asks one of those Boolean expressions, so less than sign, greater than sign, equals, not equals, that evaluates to true or false. One is less than true, that evaluates to true. So both of these variables are equal to true. Speaking of Booleans, there's also Boolean operations. If you have two things that evaluate to true or false, you can use and, or not to combine them. So if A is true and B is false, both true is equal to A and B. So if I define that variable, both true will be false because it would only be true if both A and B were true. Either true is equal to A or B in this example, and this variable I create called either true is going to turn out to be true because the or operator is going to be true if either thing on its left or the thing on its right is true. And finally, the not operator takes whatever expression is to its right and inverts it. So if the expression was true, it becomes false. If the expression was false, it becomes true. So not A, since A is true, becomes false. And therefore, this variable I declared called opposite takes on the value false. That's what we got for Booleans. The other great concept that we talked about on Friday, which is really worth saying again, is we get to use for loops in Python, just like in Carol. The one really important difference between Python and Carol is that now when we write for loops, we can actually take advantage of the fact that we know that that thing I in the for loop is a variable. So check out this example. And if you don't understand this example, you should pause, go ask somebody on Ed, go find a friend, and make sure that you do understand it. This example says for I print I. It's a for loop, it's going to repeat 10 times, but it's now taking advantage of the fact that there's a variable I, which keeps track of how many times the for loop has completed. So this is the output of that example. It prints 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Anytime you're in a for loop that's formatted like this, you have access to I. Use it to help you solve equal problems.
So at this point, I actually want to challenge us intellectually. I want us to think through what happens when you put a for loop in a for loop and extend our knowledge and our understanding of the idea that a for loop gives us access to a variable which keeps track of how many times it has completed the for loop. So if you have a for loop, it has a variable. This one we're going to call I, and it keeps track of how many times this loop has completed. But this for loop has a for loop inside it. Technical terminology, we call this the inner for loop and the outer for loop. And this inner for loop is going to be repeating as well. And this time it's going to keep track of how many times it's completed as a variable j. Thinking through what this does step by step is very helpful. It's advanced, but it's very helpful. So let's see if we can do this. So when this program starts, all it does is it prints the character I and it prints the character j. So in our terminal, we've got I and j. Then we enter the outer for loop. And let's take this step by step. So this outer for loop is going to run 2 times. I is going to take on the value 0, and then I is going to take on the value 1. So the first time you go through this loop, I will take on the value 0, and I've written I over here. Then we're going to run every line of code inside the body of this outer loop. Let's jump in. The code inside this loop is the for loop itself, which is going to have a character j. The j in this inner loop is going to keep track of how many times the inner loop is completed. So j is going to take on the value 0, then 1, and 2. Remember that this inner loop is going to repeat 3 times. First, j is equal to 0, and let's think what happens in this case. So now we've hit this print statement. In this print statement, it's printing out the value of I and the value of j. In this part of the code, you have access to both the counter for the outer loop, how many times is the outer loop finished, and a counter for the inner loop, how many times is the inner loop finished. Neither loop has finished at this point, so it's 0 and 0. But what happens when you're done with this print statement? Does it go to the outer loop? No, it's got to finish this for loop before it moves to continuing on this outer for loop. So what happens after this print statement? It goes back up to this for loop, and now j is ready to take on the value 1. Here, j is going to take on the value 0, then 1, then 2. We've just finished 0. Now, time for 1. When j is 1, it's going to print I and j. I was still 0. I hasn't changed because we haven't even finished one iteration of the outer loop. we have finished one iteration of the inner loop. So we've got I0, J1. Now we're done with this, and what happens? We keep repeating. We're going to keep repeating until this for loop, this inner for loop is done. So the next time, J will take on the value 2, and when we print, I is still 0. We haven't finished the outer loop once, but we finished this outer loop now twice. This inner loop is now run 3 times. It ran J equals 0, then J equals 1, then J equals 2. All the while, I was just equal to 0. At this point, we've finished with the inner loop. The inner loop is like, I've run 3 times, I am done. And now we finish the body of this outer for loop a single time. This is the very first time that we finish this loop, and I can go on to take on the value y. So now we finish the outer loop 1 time, and what do? It's now time to repeat. So I was 0, now I is 1, and it's time to repeat what's in this outer loop. I won't go over all the nitty-gritty, but what we're going to repeat is we're going to repeat the body and this body. So J will take on value 0, then 1, then 2, all the while that I equals 1. So the second time we run the outer loop, it will repeat this for loop. And this for loop will have J take on value 0, then 1, then 2. And this time I equals 1. So how many times did the print line run? The print, that line, it ran 6 times. 1, 2, 3, 4, 5, 6. 3 of the times I was 0, and 3 of the times I was 1. And when I was 0, J took on all its values, and when I was 1, J took on all its values. So if this thing runs twice, and for every iteration, it runs this thing 3 times, the number of times this line will run will be this number multiplied by this number. 2 times 3 equals 6. Nested for loop is going to feel advanced for a lot of people, but if you can think it through, you've really hit a large level of sophistication of understanding this variable inside of for loop. So if you guys recall, on Friday, I gave you guys this challenge of the CS106A code in place game show. And I said, here's some code, read it, and we'll come back on Monday and we'll play a game. Normally if this was a regular lecture hall, I get one of you guys to come on stage and we would play the game show. But you guys are all sheltering in place as you should be. So what are we gonna do? I went around my house, I looked for volunteers, and I found one. Everybody, this is my dog, Simba. Hey, Simba. Hi, Kass. And Simba's gonna play the game show with us. Does that sound good, Simba? Okay, try this. So Simba, pay close attention. How this is gonna work is you're gonna run a code called the game show. And first, it's gonna have you choose a door. You can choose door 1, you can choose door 2, or you can choose door 3. What you do? It's gonna go through while loop, so make sure you choose door 1, 2, or 3. And the way you're gonna choose which door is you're going to be deciding based on what you think the code is going to do. Depending on which door you choose, it's going to execute different code. If you choose door 1, it says prize equals 2 plus 9 divide by 10 times 100. Door 2 has this locked equals prize mod 2 does not equal 0. And if not locked, prize plus equals 6. And then finally, if the door 3 is your choice, Simba, then it's going to do a for loop. So Simba, I want you to think deeply, which door would you like to choose? And while Simba's thinking, you guys can also choose. If you were in this situation, which door would you pick? Would you pick door 1, door 2, or door 3? Okay, so let's go over to Simba. This is the code that I just showed you. It says, welcome to the 106A game show, choose a door and pick a prize. You're gonna choose a door, and then afterwards, we're gonna run the code that I just showed you. So think about what you want. Let's get Python gameshow.py. Okay, Simba, which door would you like? Okay. You can whisper to me. Oh, you choose door 2. That's an interesting choice. So we're gonna put in door 2, and it says, Simba, you just won 10 treats. Congratulations! Isn't this your happy thing? Woo! 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 Okay, thank you very much, everybody. Say thank you, Simba, for participating. Okay, now that Simba's off in the speech, we can think about what the other doors would have done. So we chose door 2, and again, gave us 10 treats. Why did it give us 10 treats? Well, the key to understanding why it gives you 10 treats is really this piece of code right here. So if you choose door 2, you enter this chunk of code, and locked is going to be a variable, and locked is going to be equal to prize mod 2, whether that's different from 0. So what's prize mod 2? Well, prize was 4, and if you take 4 and you mod it with 2, that produces a 0. Remember, the mod says how much is left over if you divide by the number on the right. So if you divide the number on the left by the number on the right, there's 0 left over. If you divide 4 by 2, there's no numbers left over. If you divide 5 by 2, well, 5 divided by 2 would give you 2 with 1 remaining. So that would produce a 1. The mod would give you back a 1 back if prize was 5. If prize was 6, what's 6 mod 2? Well, that's 0 again, because 6 divides evenly into 2. So prize was 4. 4 mod 2 was 0. Is 0 different than 0? No. So this becomes false. And not false, so not locked, will look up what values in locked, and that will be false. And not false will become true. So if true, think of this as if true, prize plus equals 6. So prize was 4 plus equals 6, and you get 10 treats. Great, door 2 is fantastic. But you might be intrigued about some of the other doors. Like, for example, doors 3, it's got this for loop. We know loops are going to be running lots of times. So if we add to prize lots of times, will we get even more treats? Well, it's worth thinking about this piece of code here. So if we're thinking about door 3, this is the code that's going to run. And it's going to say, for I in range door. Door is 3, so this is going to give you the range of 3. And what that's going to have I do is I is going to cycle through the values 0, 1, and 2. So range of 3 will give you I the values 0, 1, and 2. Remember, those are the number of times that the loop is completed. So at first the loop's completed 0 times, then the loop's completed once, then the loop is completed twice. The loop runs 3 times, so it's never in the loop after it's completed 3 iterations. So prize was 4, so prize used to be equal to 4, and then we add 0, and then we add 1, and then we add 2. So each time we're adding I, and I takes some values 0, 1, or 2. 4 plus 0 plus 1 plus 2, that leads to 7. Oh yeah, so maybe door 3 is not quite as good. Door 1 gave us 10, 2 gave us 10, door 3 gave us 7. Maybe door 1 is the door that holds all the treats. So at this point, maybe you're thinking, maybe we should take door 1. Actually, door 1 looks very appealing. This equation might end up being a really large number. For door 1, the key piece of code is this one. What does this 9//10 do? 9//10 is what we call the integer division. And it says, take the number on the left, divide it by the number on the right, give me the result as an integer, and throw away anything remaining. So, for example, if you do 20 integer division with 10, that says take 20 and divide it by 10, and give me how many times it goes in, and throw away any remaining. So 20 divided by 10 becomes 2 exactly, and there's nothing remaining. So it gives you back 2 as an integer. 10 divided by 10, integer divided by 10, that would give you back 1 exactly. But what does 9 divided by 10 give you? So 9 goes into 10 0 times with 9 remaining. Integer division is actually going to give you this back as a 0. And you can try this out. We can go into the terminal, and we'll do that in a second. You'll learn that 9 integer division by 10 actually gives 0. So this term here provides us with a 0, and 0 times 100 is still going to be 0. This door, only gives 2 treats. And we can try this out. If we go into the terminal, so click here to activate the terminal, we can try out some Python commands. So if you look up here, we've got a few interesting commands. We tried this 9 integer division by 10, and we got back 0. 10 integer division by 10 says, how many times does 10 go into 10? It goes in once. How many times does 20 divide go into 10? It goes in twice. How many times 9 go into 10? It goes in 0 times with 9 remaining. If you want to know the number of values remaining, you could do 9 mod 10, and I'll say, oh, you have 9 remaining. And of course, this mod was the key I did here. If we have 4 mod 2, the prize had value 4. that gives you back 0. So we understand this line, we understand this line, and we understand this for loop is going to add 0 plus 1 plus 2, and we can try it out. So we can run this program, and this time let's pick door 1, and it gives us only 2 treats, because this became a 0 times 100. And if we run this and we pick door 3, you get 7 treats. So, Simba, you chose well. Door 2 got you the most number of treats. And 0 times 100 is still going to be 0. This door, wah wah. Welcome back, Code in Place. In this lesson, we're going to do something very exciting. From day 1, we've talked about how important functions were. We were defining functions on the first day of Carol. Today, we're going to extend that knowledge to be able to define functions which can do 2 new things. Functions will be able to take in information, and functions will be able to give information back. And this will allow you to know everything you need to know about functions to write great programs. To motivate this, and why it's so important to revisit functions at this point, let's go back to that game show program that we used during the review of this class. Let's go back to that function, let's go back to that program, and let's see if we can break it apart into smaller pieces. Let's do that decomposition that we said was so important in the world of Carol. So let's go over, here's our program, and we're like, it's all in one big main function. We don't want our program to be all defined in one big main function, especially when there's these nice decomposable pieces, right? This whole chunk of code is just asking the user to give a valid door between the range 1 and 2. How much nicer would this program be if instead of having this chunk of code in the main function, we just said get door? And somewhere over here, we define get door, and we can put our code there. And if people are interested in the details of how you get the door, they can go check it out. But if they're not interested in the details, then they can skip over it. This whole chunk of code similarly does something pretty decomposable. This is computing the prize. So let's say compute prize to make it an active verb. So in our desire to make this program more elegant, I want to put all the code into compute prize. This program now looks a lot more readable, right? You have your intro printing, then you get the door, then you compute the prize, then you print, you win prize treats. Fantastic. What a better stylistic program. Now, we've been doing this in the world of Carol. Why weren't we always just doing this in the world of variables? Well, let's run this program and see how it breaks. When we run this program, it starts by doing this print. Okay, great. Welcome to the Code in Place Paint Show. Good times. Then it calls get door. When it gets to get door, it jumps into this chunk of code and starts executing. And it says what door we'd like. We know that door 2 got all the treats. So we're definitely choosing door 2. If it enter, it crashes. Why does it crash? The program used to work just fine. It tells you exactly where it crashes. It crashes on line 14. Line 14 is in compute prize, and it says if door equals 1. What's wrong with that line? Python tells us exactly what's wrong. It says door is not defined. In the world of Python, with variables, there's something important you need to know. Variables are not visible to the entire program. They're only visible within the functions they're defined. So if you define a variable within get door, which is called door, it's not immediately visible to compute prize. This is very intentional. It allows, if all variables were in today's class, you'll learn how to define these functions. Before we jump into semantics, I wanted to give you a very nice metaphor for thinking about functions that receive information and give information. A great metaphor for those functions, like square root, for example, is a toaster. Toasters are like functions. Toasters are like functions in that they can receive stuff. Toasters receive bread-like stuff. For example, bread. If you put bread into a toaster does its mechanism, it does its actions, and it gives something back. It gives back toasted bread. A beautiful thing about a toaster, though, let's say you didn't have bread, but instead you had a bagel. Do you need to go get a bagel-specific toaster? No, you can use the exact same mechanism, the exact same machine on this different type of information that's coming in. If you have a bagel and you put it into a toaster, it's not going to crash. It's like, I know how to handle a whole bunch of different types of information coming in. Bread, bagels, you name it. And if you give it a bagel, it'll give you back not toasted bread, but a toasted bagel. That makes sense. Now, toasters don't work on any type of image. There's some information it's fine with. Anything that's bread-like, it's like, I can handle this. I can make use of toast version of your bread-like input. But if you put in a fork, don't try this at home. It doesn't work at all. Toasters only work on a specific set of assumed inputs. Another crucial way that functions are like toasters and toasters are like functions is that there's really two different characters involved in a toaster. There's the person who builds the toaster and the person who uses the toaster. Sometimes they're the same person, but often they're different. If you want to use a toaster, you don't need to know how it's built. So I could tell you that a toaster works by having coils that heat up, and that's how it takes bread and turns it into toast. Or maybe the way a toaster works is that there's magical elves that live in the toaster. When you put in bread, they cast their spells and they turn their bread into toasted bread. As the user of the toaster, you don't need to know how it's built. You can just use it by saying, every time I put in bread in here, I get toast out. That works for me. That separation between the person who creates the toaster and the person who uses it, crucial for us to advance as a society. Same thing for us advancing as a society of programmers. The more we can build functions that other people can use without knowing how they're built, without having to spend the time building them, the more and more sophisticated programs as a big community will be able to build. Now, toasters are like functions, but the one way they're different is you might think a toaster is a little bit boring. It does make bread. Functions are anything but boring. They're one of the crucial concepts of computer science. So maybe it's like a toaster that's awesome, like a Star Wars toaster that makes all your bread have a little typo. I would say that functions that take in information and give them back are one of the most underrated concepts by students that I teach. So 106A students or code and play students. This is really a crucial idea. Unfortunately, it's easy to skip over it because the ideas we'll teach you here are not going to change the sort of programs you can write. It's just going to change how elegant your programs are. Now, if you don't learn the concepts that we talk about today, you'll really have a ceiling of how sophisticated your programming can get. And if you can master these concepts, the world is going to be your oyster. I know it's hard, but I really encourage you to spend the effort to understand the concept in today's class. You have plenty of practice on the website for today's lesson, and you'll get lots of chances to use it in this class and beyond. As a little bit of an aside, a lot of times people ask me, what does it take to get from Carol to making something like a Pixar movie or a great game or a web app that exists on your phone? And the answer is really this ability to build on top of what other people can do. And if I have to name one concept that's most crucial to advancing us to complicated levels of programming, it's really functions that can take in information and give them back. Okay, so let's jump into things. We've been defining functions for a whole bunch of time in code and place. But the functions that we define wouldn't take in information or give it back, and that's the big difference. I wanted to start by just showing you an example to build some intuition. I have a contrast here. On the left-hand side of your screen, you see one example of a function. This one takes in no information, and it doesn't give any information back. On the right-hand side of the screen, to build some intuition, I want to show you a contrasting function that does take in information. This information that's taken in is how many times you want to print root. Now, on the left, every time you run this function, it always prints root exactly 3 times. On the right, every time you call this function, the number of times it prints root depends on what information you give it. Let's go try this out for a spin. So we can go over to our function root. And to build some intuition, here's root, and this function is going to take some information. It's going to refer to it as num ever through its definition. And when we call root, if we call it with information, it will perform different actions. So if we say, hey root, I'm going to give you a 5, it prints root, 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 root. If you say root, I'm going to give you a 7, and we run this program again, it goes root, 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 root. Of course, you know, you could have just put like a 5, or you could have put a 7 here, but really this is a nice separation. Here when you call root, you get to put the number right there. You don't have to get into the nitty-gritty of the for loop. You can separate different parts of your program out and just say like, root needs some information. How many times do you want root? You're like, oh, I know how many times I want root. I want root 100 times. It's like, sure, there's 100 roots. Beautiful separation of different parts of our program, and it just required us to be able to write a function that could take in information. So this is a little bit of contrast to build some intuition. Of course, I'm going to go over this in total detail so you can understand every single part of what's going on here. But hopefully by showing you these two side by side, you can start to get a feel for what's different between a function that doesn't take information and a function that does. Okay. Let's get into the nitty-gritty of the definition. If you want to be defining functions, taking information, and giving them back, there's a few things you need to know. This slide has most of them in it. I'm going to introduce you to the anatomy of the function that takes information and gives it back. Before I do so though, I want to make sure we're always really clear that there's 2 different roles here. There's the role of the person defining the function. That's the person who's adding this idea to our vocabulary. It's like when we define turn right. That's separate from the part of your code that calls the function. You know, there's the part of your code which would invoke turn right. That is a different part of your code. So we're going to separate the part that's calling our function. In this case, we're calling our function average. And the part of your code which is defining what average is. Now, a little bit of anatomy. We call this thing a function definition, and we call this thing a function call. When you define a function, you write def, and then you always give a name. Every function has a name. What's new is that now between parentheses, you can say that this function expects some information. The way you say that is you write names for the information you expect separate by commas. This is saying I expect 2 pieces of information. I'm going to call the first one A. If you define a function that expects information, when somebody calls your function, they better provide you information. That information could come in terms of literal numbers or variables, whatever it is. Whenever you call this function, you better be giving 2 pieces of information. Why 2? Because it asked for 2. So, between parentheses, we can give information expected, and when calling it, between parentheses, we can provide that information. There's formal names for this. When you're calling a function, that information you provide, we call those the arguments. And when you're defining a function, that information that you're receiving that you'll use to execute your function, we call those parameters. That technical jargon is not nearly as important as understanding how to use this functionality. Every function's got a body, and in the case of a function which is taking information, it can use that information in the body. So in this body, it can use A and it can use B in order to do its calculation. In this case, calculating the mathematical average of A and B. It can take A plus B, get a sum, divide by 2. When this function's done, it wants to give information back. If you want to give information back, what you use is a term called return. You write return, and then after a space, you write whatever information you want to flow back to the caller. This is saying, I'm going to give something back to the caller. What I'm going to give is information. What information? Sum divided by 2. That will be packaged into a little piece of information which will be given back to the caller. The caller is then going to receive information. So when average is called, computations will be done and information will flow back. The caller can do a bunch of things with the information. One thing it can do, it can take that information and store it into a little box variable. It can do other things like use it immediately in print state. The choice is up to the caller, but basically, if a function returns some information, it will flow back to the caller. This is also a function definition. This is the definition of main. Definition of main has no parameters and it has no return. It's still a function definition, but today we're going to be focusing on function definitions of functions that take an information and give them back. So, formally, a function looks like this. It has a name, how you refer to the function, has parameters, that's information it expects to be passed in, and it can have returns, which are information that will be given back from the function. Key idea. Parameters are the way that you can say my function needs to be receiving some information. When you call my function, you better provide some information. I'm going to ask this question a whole bunch of times during this lesson. Why? Because I've seen students make this confusion all over the place. I just told you about returning, where returning allows you to give information back. And I'm going to ask you, is returning the same as printing? And whenever I ask you this question, I want you to say, no, Chris, returning and printing are two separate concepts. We'll get deeper into it. Okay, so when you return, when somebody calls average and you return, that's not the same as printing. Let's look at the difference. One way, though, of thinking about a function that receives information and gives it back is really to be specific about imagining a caller and an author, and imagine this amount of information flowing in and out as being a contract between these two characters. The caller says, I'll call your function, and the author says, I'll write your function for you. A little bit like somebody uses it and somebody builds it. The contract says, if you want to use this function, you have to give me some information. In this case, I'm saying you have to give me two pieces of information, which I call parameters. The contract then says, I will then give you back information via a return value. This contract allows the caller to know exactly what to expect. I expect to be giving in two pieces of information and receiving one back. I think it's very helpful to separate all the different users, all the different characters in our program. So far we've got a character which is calling our function. We have a character who's the architect, the author, the builder of the function. And then there's also a user. That's the person who's maybe putting inputs into a screen and maybe seeing prints show up on their console. Let's think about these as three sets of characters throughout today's class. This tiger we'll use to refer to the caller, this little squirrel we'll use to refer to as an author, and we'll use a penguin for the user. it's done. So this is a really gentle introduction to functions. We've seen a lot of functions like this already. Let's bump this up a notch. Let's look at a function that takes in some information. This function I'm going to define, and I'm going to call it print opinion, and it's going to take in some information. The contract is you have to provide one piece of information. This definition is going to, in its operations, refer to that information as num, and it looks a lot like a variable. Again, we have the caller, we have the definer, and we have the user. So the user starts the program print opinion. It starts the main function, and then it calls print opinion. Print opinion now is going to execute. But check out what happens. What happens to this 5? Well, print opinion, it has its own variables, and it really treats this piece of information, this parameter, it treats it like a new variable. It's got a new variable, its name is num, and what value goes into it? Well, that's whatever information is flowing in. That's a mechanism for flowing information from the caller to the definer. So the caller gave the 5, and the definer received the 5 as a variable called num. It can now proceed to calculate this expression using num. So you can say, is num the same as 5? And the case is like, yeah, when I look up the value of num, it's 5, that's the same as 5, and it prints, I love 5. The user then sees, I love 5. Printing the same as returning? No. So this is not the same as returning 5, or returning I love 5 back to the caller. Instead, it's pointing it directly to the user. This if statement's done, the function's over, all this information goes away, and we go back to our main. That's how we pass information in. So let's try this one more time. This function also takes in information. It expects information, one piece, and it's going to refer to it like a variable called meters. What's different about this function is that in addition to expecting some information, it's also going to give information back. I know that because I see it's got a return statement. So when you call this function, the first thing that happens in main is it calls meters to centimeter. In this case, it passes in a 5.2. That 5.2, what happens to it? Well, when we call meters to centimeters, it's like it sets up a variable called meters and puts in the number 5.2. It then executes this program, this function, using meters as a variable. So it takes meters, multiplies by 100, 5.2 times 100 is 520, and then it returns it. When it returns it, does that get printed to the user? No. Printing is not the same as returning. It doesn't mean it pops up to the user's terminal. What returning means is it's given back to whomever called it. Whoever called meters to centimeters, that execution now looks like it's been replaced with the information that came back, that 520. And so now result equals 520 looks like it's going to take this returned value and put it into a new variable in main called result. Again, nothing's been printed to the screen. When you return, you're not returning to the screen, you're returning to whomever called you. Finally, when we print result, that goes to the screen. So now you can see why it's really useful to think about the screen and the user as being different from the person calling the function. When you return, the function definer is giving information back to the caller, and then it's up to the caller to then pass that back on to the user. Let's go actually look at this function. So meters to centimeters. Here's a slightly expanded version. I've got the function, I define meters to centimeters, and it takes in input and it calculates as a result. As you'll notice, there's one big difference between what was on my slides and here, is that I have a comment. These comments are crucial. I don't always have space on my slides for comments, but I always have space in my code for comments. And when I write a function, I almost always leave a little comment that says what this function does. My comment here says, it takes in meters as incoming information. It then returns the corresponding centimeters. It says what it does. This is the definition of the function, and here's where it's called. And in this set of code, I've added one extra line, which is get information from the user. So here I'm going to get some information from the user, which is the number of meters. Then I'm going to call my helper function. that's going to return back the result of meters to centimeters. It doesn't print it to the screen, so it's up to me to actually output the result. So we can run this program, enter meters, and we can say 9.1, and it prints out 910. We could update it so it says centimeters in addition to 910, but hopefully you get the idea. We have a function, it takes in information, and it gives back information, and I'm using it like this. From the user, I get a number of meters. I call that a variable, which then I use as my information pass to meters to centimeters. That gives me back a result, which I store in a new variable, and then I print that back for the user. This is a really beautiful paradigm. We love functions like meters to centimeters. Meters to centimeter doesn't have any input and it doesn't have any printing. Instead, it's just performing all the mathematics. It's great because it makes it so usable. This is just something to help your programmer. It's not directly being used by the user. Instead, it's helping the programmer do some task. And by having a function which is so clean and doesn't have any input or prints, it makes it so usable by lots and lots of different programmers. We love functions like this. Okay, when you have a function, just like in Carol, you can use it lots of times. So if I define meters to centimeters, I can call it a few times. So here in this main function, I'm going to call meters to centimeters. First time I'm going to call 5.2, it gives me back 520. And then I'm going to print it to the screen. And the second time I'm going to pass in 9.1. And it will give me back 910. It's like a toaster that can be used with a whole bunch of different types of bread. We can pass in any number and it'll give it back to us as centimeters. This 910, that result, I'm immediately putting into a print statement so it shows up on the screen. If you define a function, you can use it a whole bunch of times with different parameters. So here's another contrast for you to think about. What is the difference between this function up here, meters to centimeters case 1, and this other function, meters to centimeters? I want you to think about it. If you're in a private space, feel free to shout it out loud. What is the difference between these two functions? Well, if you look closely, one of these functions is returning, and one of these functions are printing. What does that mean? Well, here's one way to think about it. When a function produces a value, does it print or does it return? If it prints, that value immediately goes to the console for the user to see. If it returns, instead you're giving it back to whomever called you. It's not directly going to the user. Instead, it's going back to whomever called meters to centimeters. This one is great because they can store the result. They can use it lots of times. They can add in some nice formatting. They can do lots of other things in addition to just printing it. So whenever possible, if you have the option to return instead of print, that's often a great choice. So anyways, the big difference between these two functions, one's returning and one is printing. So, question for you, is returning the same as printing? No! They're two totally different things. They both feel like information coming back from the function, but one goes directly to the user and one goes to the place in code where the function is called. Similarly, input is not the same as parameters. Same difference. Input is information coming directly from the user into your program, and parameters are information flowing from the caller of the function to the person defining it. When you have functions, you can have multiple return statements, and something you need to know about return is as soon as your program hits a return, it stops that function and gives back information. It doesn't care about the other lines of code in the function, it immediately halts. So here's a simple example. It's a max function. This max function is supposed to take in two numbers and give you back the larger of the two. Let's see it in action. So here I'm going to call max. Max takes two pieces of information called num1 and num2. And this time when you call it, you have to provide that information, so I'm going to provide it 5 and 1. When you call max with a 5 and 1, you can imagine it has two variables. One's called num1, one's called num2, and the first one's going to be populated with 5, and the second one's going to be populated with a 1. Why? The order matters. Whatever you pass in 5, 1 is going to map directly to the order of the names of these parameters. So I'm going to call the first one num1, that gets the 5. I'm going to call the second one num2, that gets the 1. So boom, 5 goes there, boom, 1 goes there. Now we can do the operations for maxes. The first line in map text is num1 greater than or equal to num2. Well, is that true? If it looks in num1, that's a 5. If it looks in num2, that's a 1. It's 5 greater than 1? You betcha. This if statement passes. So what happens next? We enter the if statement body. In the if statement body, you see that there's a return. What you need to know is as soon as this function hits a return, it will immediately exit. It won't run the rest of this code. It immediately stops and says, I've got my answer. The answer it gives back is whatever was in num1, so it gets this 5 and it gives it back to the caller. This function stops immediately. All this goes away and it just is replaced with 5. It doesn't execute this line of code. It hit the return and it was done. Interesting, right? It's just something for you to know. So now it's come to 5, larger takes the value 5, we're done with this program. Let's try this again, let's flip those variables and let's just see how this function with multiple return statements is going to operate now. So again, let's trace through this. We call main. The first thing in main is to call max. Max passes in 2 pieces of information, a 1 and a 5. This time, num1 will get a 1 and num2 will get a 5. Why? Order matters. Num1 will be mapped to the first information passed in, and num2 will be mapped to the second piece of information passed in. So, whoop, get a 1, get a 5, which was reversed from what we had last time. That means that when we see this if statement, is 1 greater than or equal to 5? Nope, it's not greater than or equal to 5. So we don't hit that this return statement we hit previously. Instead, we hit this return statement, which returns back num2. What's num2? 5. Makes sense. If you do max of 1 and 5, it gives you 5. If you do max of 5 and 1, it also gives you 5. This function is working as it should. So now, max of 1 and 5 gives you back a 5, so larger now stored in the fantastic. Instead of print, think about what is the difference between this function up here, meters to centimeters case 1, and this other function, meters to centimeters case 2. I want you to think about it. If you're in a private space, feel free to shout it out loud. What is the difference between these two functions? Well, if you look closely, one of these functions are returning and one of these functions are printing. What does that mean? Well, here's one way to think about it. When a function produces a value, does it print or does it return? If it prints, that value immediately goes to the console for the user to see. If it returns, instead you're giving it back to whomever called you. It's not directly going to the user. Instead, it's going back to whomever called meters to centimeters. This one is great because they can store the result. They can use it lots of times. They can add in some nice formatting. They can do lots of other things in addition to just printing it. So, whenever possible, if you have the option to return instead of print, that's often a great choice. So anyways, the big difference between these two functions, one's returning, one is printing. So, question for you, is returning the same as printing? They're two totally different things. They both feel like information coming back from the function, but one goes directly to the user and one goes to the place in code where the function was called. Similarly, input is not the same as parameters. Same difference. Input is information coming directly from the user into your program, and parameters are information flowing from the caller of the function. When you have functions, you can have multiple return statements, and something you need to know about return is as soon as your program hits return, it stops that function and gives back information. It doesn't care about the other lines of code in the function, it immediately calls it. So here's a simple example. It's a max function. This max function is supposed to take in two numbers and give you back the larger of the two. Let's see it in action. So here I'm going to call max. Max takes two pieces of information called num1 and num2. And this time when you call it, you have to provide that information. So I'm going to provide it 5 and 1. When you call max with 5 and 1, you can imagine it has two variables. One's called num1, one's called num2. And the first one's going to be populated with 5, and the second one's going to be populated with 1. Why? The order matters. Whatever you pass in 5, 1 is going to map directly to the order of the names of these parameters. So I'm going to call the first one num1, that gets 5. Call the second one num2, that gets 1. So boom, 5 goes there, boom, 1 goes there. Now we can do the operations of max. The first line in map says, is num1 greater than or equal to num2? Well, is that true? It looks in num1, that's a 5. It looks in num2, that's a 1. Is 5 greater than 1? You betcha. This if statement passes. So what happens next? We enter the if statement body. In the if statement body, you see that there's a return. What you need to know is as soon as this function hits a return, it will immediately exit. It won't run the rest of this code. It immediately stops and says, I've got my answer. The answer it gives back is whatever was in num1, so it gets this 5 and it gives it back to the caller. This function stops immediately. All this goes away and it just is replaced with a 5. It doesn't execute this line of code. It hit the return and it was done. Interesting, right? It's just something for you to know. So now it's got the 5, larger takes the value 5, we're done with this program. Let's try this again. Let's flip those variables and let's just see how the function with multiple return statements is going to operate now. So again, let's trace through this. We call main. The first thing in main is to call max. Max passes in two pieces of information, 1 and 5. This time, num1 will get a 1 and num2 will get a 5. Why? Order matters. Num1 will be mapped to the first information passed in, and num2 will be mapped to the second piece of information passed in. So boop, we get a 1, boop, we get a 5, which was reversed from what we had last time. That means that when we see this if statement, is 1 greater than or equal to 5? Nope, it's not greater than or equal to 5. So we don't hit that other this return statement we hit previously. Instead, we hit this return statement, which returns back num2. What's num2? 5. It makes sense. If you do max of 1 and 5, it gives you 5. If you do max of 5 and 1, it also gives you 5. This function's working as it should. So now, max of 1 and 5 gives you back a 5, so larger now stores the value function. Fantastic. Lines of code, but it was crashing. It was crashing on this line because it says, I've never heard of your door. We said a really important thing for you to know is that different functions don't all get to see the same variables. It's not like door lives throughout the entire scope of your program and every function can see it. for very specific reasons, we encapsulate variables to the functions in which they're defined. That means that when you get to getDoor and you define this variable door, that doesn't live forever. It's not going to be visible in compute prize. That's why it's so important that we know how to pass information back and forth. GetDoor, it doesn't need to receive any information, but this getDoor function, it actually is going to be generating a variable which we're going to want to give back. When we call getDoor, it's going to ask the user for a door number, but when the user is done entering a door number, getDoor has access to this variable, and we want more functions to have access to that variable. So we want to pass this information back. We want getDoor to return it to whomever called it. So crucially, we can say return door. The return door, now this function is going to be giving information to whomever calls it. So let's write a comment. GetDoor asks the user to enter a door, reprompts the user until they enter 1, 2, or 3. Return the valid door choice. GetDoor now gives you back some information. So if we go back here, when we call getDoor, it is very conveniently giving us back something which I'm going to call door. So if we go over here and we print door, it should print whatever was chosen in this function. This variable has now been given back as information. So if we run this program, we put in door 2, it printed out a 2, so when it got to this print line, it printed out that 2. It's still crashing though. It's still crashing on this line. The main function now knows about door because getDoor provided it back to the main function. Compute prize though never heard door. This main function, it received that door. Its task is now to pass that information on to compute prize. So when you call compute prize, it needs information. When you call compute prize, and let's write a comment, it needs to know which door was chosen. So compute prize calculates how many treats you win, and it's based off the door which was chosen. If we want this to receive information, we should be writing something between parentheses. I want to show you what happens when we forget. Let's try. Let's see what happens now that we say, okay, compute prize, we really want to be getting a door. So that's the information you need to compute the prize, but I forgot to write door between these parentheses. What's going to happen? We put in a 2 and it crashes. And it says something quite interesting. It says, compute prize takes 0 positional arguments, but 1 was given. Oh yeah, compute prize, it was given an argument, that's what you call a parameter on the given side, but we didn't say in our contract that we really expected a parameter. So here you can say, I really do expect a parameter. When you call compute prize, I really want you to give me some information, and I'm going to refer to that as door. So now getDoor called a function which gave some information back. Compute prize then is going to be passed on that information, which was the door value. If we run this program, it's now going to work, right? Because compute prize is now being given the information, which is the door. Now that it's got access to the door, it can say, is door 1, else is door 2. So now we choose door 2. We got a lot further, but our program still crashed. It's now crashing on this line, which is line 10. This line executed fine, this line executed fine, but this line didn't work. It says, I've never heard of this prize variable you talked about. The exact same problem has shown up. Prize is something which is defined in this function. That means it's not known to the main function. If you want it to be known to the main function, The mechanism for doing that in Python is to give information back to the caller. The main function is the caller. The main function calls compute prize, so compute prize needs to give it back to the caller. It needs to give prize back. How do we give information back? Well, compute prize is already receiving information. It should be returning the prize which is calculated. At the end of this function, if we want to give the information back, which was the prize calculated, we should write return prize. Now this function takes in information, which is a door, and gives back information, which is the calculated prize. Whenever a function gives you back information, a best practice is to immediately store into a variable. In this case, I'm going to call my variable the exact same thing that I called it in compute prize. They don't have to have the same name, but it's super convenient for them because they're referring to the same idea, which is a prize. Now this program runs without a hitch. It does the exact same thing it used to do, but it's been nicely decomposed. We call getDoor. That function takes no information, but it gives us back a door. We then call compute prize. That needs to know which door was chosen, and then it gives us back a prize as a number. And then we can say, you win prize treats. Beautifully decomposed, and there's information flowing in a really controlled way. You know, the main holder of information is the main function, and getDoor, it doesn't need any information, so we don't give it any. And it needs to give back information. It needs to say which door was chosen. Compute prize, the only thing it needs to know about was what door was chosen, and it will give you back a prize. So that's really the contract it's signed. And the main function puts it all together. And when you read this, it's like, okay, great. I've got an intro, I get a door, I compute a prize, and then I say you win prize treats. It's a much more beautiful program. Now, for a program that's only about 20, 30 lines, can you get away without decomposition? Sure. If you want to write all of Chrome, or if you want to write all of Doodlejump, your favorite application on your phone, are you going to be able to do it without functions that pass in information given back? Absolutely not. It's a crucial skill. Now, I've got a challenge for you. On your assignment, a lot of your programs are a little bit too short for functions. However, the game of NIM has a place where it says, can you enter a number of stones to pick up? That process of saying how many stones to pick up is really similar to choosing a door. I challenge you to see, can you take that part of your assignment 2, and can you write a function for it? Of course, in assignment 3, we'll get deeper into functions, but there's my challenge for you for assignment 2. I hope you guys have a wonderful day. Thank you so much for sticking around for this great class, for trying really hard to learn this incredibly important and incredibly difficult concept. You guys rock. I respect you. I appreciate you. Have a fantastic day, and we'll see you back on Wednesday for the next installment of Put in Place. getDoor now gives you back some information. So if we go back here, when we call getDoor, it is very conveniently giving us back something which I'm going to call door. So if we go over here and we print door, it should print whatever was chosen in this function. This variable has now been given back as information. So if we run this program, we put in door2, it printed out at 2, so when it got to this print line, it printed out that 2. It's still crashing though. It's still crashing on this line. The main function now knows about door because getDoor provided it back to the main function. Compute prize though never heard door. This main function, it received that door. Its task is now to pass that information on to compute prize. So when you call compute prize, it needs information. When you call compute prize, and let's write a comment, it needs to know which door was chosen. So compute prize calculates how many treats you win, and it's based off the door which was chosen. If we want this to receive information, we should be writing something between parentheses. I want to show you what happens when we forget. Let's try. Let's see what happens now that we say, okay, compute prize, you really want to be getting a door. So that's the information you need to compute the prize, but I forgot to write door between these parentheses. What's going to happen? We put in a 2 and it crashes. And it says something quite interesting. It says, compute prize takes 0 positional arguments, but 1 was given. Oh yeah, compute prize, it was given an argument, that's what you call a parameter on the giving side, but we didn't say in our contract that we really expected a parameter. So here you can say, I really do expect a parameter. When you call compute prize, I really want you to give me some information. I'm going to refer to that as door. So now getDoor called a function which gave some information back. Compute prize then is going to be passed on that information, which was the door that was chosen. If we run this program, it's now going to work, right? Because compute prize is now being given the information, which is the door. Now that it's got access to the door, it can say, is door 1, else is door 2. So now we choose door 2. We got a lot further, but our program still crashed. It's now crashing on this line, which is line 10. This line executed fine, this line executed fine, but this line didn't work. It says, I've never heard of this prize variable you talked about. The exact same problem is shown up. Prize is something which is defined in this function. That means it's not known to the main function. If you want it to be known to the main function, the mechanism for doing that in Python is to give information back to the caller. The main function is the caller. Main function called compute prize, so compute prize needs to give it back to the caller. It needs to give prize back. How do we give information back? Well, compute prize is already receiving information. It should be returning the prize which is calculated. At the end of this function, if we want to give the information back, which was the prize calculated, we should write return prize. Now this function takes the information to the door and gives back information, which is the calculated prize. Whenever a function gives you back information, a best practice is to immediately store it into a variable. In this case, I'm going to call my variable the exact same thing that I called it in compute prize. They don't have to have the same name, but it's super convenient for them because they're referring to the same idea, which is a prize. Now this program runs without a hit. It does the exact same thing it used to do, but it's been nicely decomposed. We call getDoor. That function takes no information, but it gives us back a door. We then can call compute prize. That needs to know which door was chosen, and then it gives us back a prize as a number. And then we can say, you win prize treats. Beautifully decomposed, and there's information flowing in a really controlled way. You know, the main holder of information is the main function, and getDoor, it doesn't need any information, so we don't give it any. And it needs to give back information. It needs to say which door was chosen. Compute prize, the only thing it needs to know about was what door was chosen, and it will give you a backup prize, because that's really the contract it's signed. And the main function puts it all together. And when you read this, it's like, okay, great, I've got an intro, I get a door, I compute a prize, and then I say you win prize treats. It's a much more beautiful program. Now, for a program that's only about 20, 30 lines, can you get away without decomposition? Sure. If you want to write all of Chrome, or if you want to write all of Doodle-Jump, your favorite application on your phone, are you going to be able to do it without functions that pass in information, give it back? Absolutely not. It's a crucial skill. Now, I'm going to challenge you. On your assignment, a lot of your programs are a little bit too short for functions. However, the game of NIM has a place where it says, can you enter a number of stones to pick up? That process of saying how many stones to pick up, it's really similar to choosing a door. I challenge you to see, can you take that part of your assignment 2, and can you write a function for it? Of course, in assignment 3, we'll get deeper into functions, but there's my challenge for you for assignment 2. I hope you guys have a wonderful day. Thank you so much for sticking around for this great class. To that as door. So now get door called a function which gave some information back. Compute prize then is going to be passed on that information, which was the door that was chosen. If we run this program, it's now going to work, right? Because compute prize is now being given the information, which is the door. Now that it's got access to the door, it can say, is door 1, else is door 2. So now we choose door 2. We got a lot further when our program still crashed. It's now crashing on this line, which is line 10. This line executed fine, this line executed fine, but this line didn't work. It says, I've never heard of this prize variable you talked about. The exact same problem has shown up. Prize is something which is defined in this function. That means it's not known to the main function. If you want it to be known to the main function, the mechanism for doing that in Python is to give information back to the caller. The main function is the caller. Main function called compute prize, so compute prize needs to give it back to the caller. It needs to give prize back. How do we give information back? Well, compute prize is already receiving information. It should be returning the prize which is calculated. At the end of this function, if we want to give the information back, which was the prize calculated, we should write return prize. Now this function takes information, which is a door, and gives back information, which is the calculated prize. Whenever a function gives you back information, a best practice is to immediately store it into a variable. In this case, I'm going to call my variable the exact same thing that I called it in compute prize. They don't have to have the same name, but it's super convenient for them because they're referring to the same idea, which is the prize. Now this program runs without a hitch. It does the exact same thing it used to do, but it's been nicely decomposed. We call getDoor. That function takes no information, but it gives us back a door. We then call compute prize. That needs to know which door was chosen, and then it gives us back the prize as a number. And then we can say, you win prize treat. It's beautifully decomposed, and there's information flowing in a really controlled way. You know, the main holder of information is the main function, and getDoor, it doesn't need any information, so we don't give it any. And it needs to give back information. It needs to say which door was chosen. Compute prize, the